just to make sure everybody's on the right plane, this is the plane that is Introduction to PaaS for Application Developers. It's presented by me, Steve Pousty. If you want, talk is being done in Reveal.js. So that URL gets you actually to the exact same slides. So talks@stevezero.com/PaaS intro. The Steve0 is my handle. It's my handle in all those places. For IRC, that's Freenode. I don't hang out anywhere else besides Freenode. And that's also my email address at Red Hat. So the stevezero@redhat.com is my email address. All right. So I'm going to tell an epic tale today of two forces who've battled for millennia, maybe even longer. I'm not going to actually, though, in this case, these are both considered evil, right? Vampires and werewolves. There's no value judgment here. They're just two groups that have battled for a very long time, right? And this fight has involved developers, who you see here. They like to sit in the sunshine. They like having MacBooks and shiny things. They like writing code. They like things being done now. They're always excited about a new language. There's a new language coming out about once every week. And so there's a new database. They got to try it. This is exciting. If I don't write my app in this new language, I'm nothing, right? So that's the developer. And on the other side is the sysadmin, right? They tend not to move in packs as much. They tend to sit in dark places, surrounded by a lot of machines. They like to think about big hardware and fleets of hardware and interesting things, and they don't usually change technology nearly as much, right? They get Zabbix, and then they're going to have Zabbix for quite some time, right? Yum, it's a big uproar when Red Hat starts talking about something new compared to Yum, right? It's a much slower moving community. And these two groups I would imagine that most of your companies have fought for quite some time. Is that true? Yeah. These are not two groups that usually get along. This is also how I characterize developers. Fast. I need things now. I'm drinking lots of caffeine. I need things done now. New. I need it right away. It's Friday at 5 o'clock, and I'm going to make a new Node.js application that's going to save this company. I'm going to be showing to the CEO on Monday. They call up the sysadmin and say, spin this all up for me now. Right? Was that pretty typical for companies? There's only 7 of us, so we can all be nice and friendly with each other about this. Okay? Open conversation. This is what life looks like to a sysadmin. That is sexy to a sysadmin in general. A nice big truck. It can haul a lot of stuff. It's dependable. That thing can probably go like 200,000 miles before it needs its first oil change. Right? And it's hauling stuff day and night, long distances. It can blow out like 3 of those tires in the back and still keep going. That is what they like. Dependability, stability, not a lot of people it's not made for having a lot of people on board, right? It gets the job done. And so this is generally how sysadmins think about the world. One does not simply log into my server, right? If you ask them to get access to a server, it usually takes an act of God, or you have to sign your life away, or they're sitting right next to you, right? And having been mostly a developer myself, but worked a lot with sysadmins, I actually think that's with good reason, because usually their machine is set up some way, and I'll go in and say things like, well, what could possibly go wrong if I do chmod 600 on my entire web directory? Oh yeah, it's definitely got to be recursive. I don't have time to sit around and think this all through. Go. Why isn't the web server working anymore? I'm not serving up any content. Right? So that's part of the reasons why they lock things down and keep us away. On the other hand, this is how developers end up thinking about the world. Right? We usually go in and say, I really need a new server. Okay, open a ticket. Okay, a week later, hey, how's my ticket doing? I really wanted a new VM. Can I get a new VM? We'll get back to you on that. We're working on the email. And it keeps going, and then they finally give you a VM, and they didn't configure it quite right, and you can't look at your log files, and then you have to go back again. And it takes you about 3 weeks between your idea. If you're at a good company, it takes you maybe if you're at a really good company, this doesn't happen. But if you're at a good company, it could take you 3 weeks to get a VM. So there's 3 weeks between your really good idea that you really just wanted to start working on and when you can actually start working on stuff. And that usually ends up frustrating developers. And so these two groups are usually at each other, right? Because they're not doing stuff fast enough. The sysadmins aren't doing stuff fast enough for me. The developers are calling me up and asking me for these things. I'm keeping the email servers running and the Oracle instance running. Why are you bugging me like this? Right? I don't care about you. You haven't even used Node.js. Why? I'm supposed to understand how to install it? Leave me alone. Right? So usually you end up with this kind of scenario. Right? The groups don't get along. Dev just develops it, gives it to the ops team. It goes over the fence and fire. And devs are like, I don't know. It worked on my laptop. Worked in the VM I had. Well, I changed a few configurations to make it do what I needed it to do. And this is when the business people start getting really upset. Right? So I'm going to try to pose a model where we can all just get along. Right? And I think platform as a service helps us to get to this situation. I think of platform service as awesome sauce, and you'll see why in a little bit. So for those of you, everybody was in there was 1, 2, 3 of you who've seen this slide already, but that's not the majority of the room, so we'll go through it again. I'm going to start with some definitions of the cloud. So infrastructure as a service. Who here knows what, the people who are in my session, you're not allowed to answer. Who here knows what infrastructure as a service is? What's the biggest example of infrastructure as a service? Amazon, EC2, right? By far the most popular. What's Red Hat's product that helps you do your own infrastructure as a service? OpenStack, right? That solves the same problem. And it's pretty awesome, right? Compared to that other model that we talked about before, where it might take you a year just to get I was just talking to a customer who I had met last summer, and they said they were ready to go with OpenShift, and it took them a year to get their hardware in. Right? And so all their devs, all their sysadmins were waiting around just for hardware. Infrastructure as a service, once you get the hardware in, or if you use Amazon, it's just, I want a new machine. I pick this configuration, and it's up in a minute or two. So that's awesome, right? And there's also not that fixed cost of, I've now got hardware that I've got to fully utilize. That project's gone away, I can just turn them off and repurpose that somewhere else. It's not great for developers, though, right? Because if a developer is interacting directly with the infrastructure as a service, they have to pick the operating system. They have to keep the OS up to date. If there's a patch, Heartbleed comes out, they have to know how to patch their machine or know that it even came out, and then go in and know how to do the patch. They have to configure the app servers. So for me as a developer, it doesn't really solve my problem. I want to write some Java code, and I want to start writing it now. I don't want to spend 5 days figuring out how to get Tomcat to talk through a mod. What is it now? Is it mod AJP, or is it some other mod now? If you're fronting with Apache, right? I don't know how many times I've wrestled with that, trying to get it to talk through Apache. So I'm like a week, 2 weeks in, and I've finally got all the yak shaving done, and it's all working. Right? And I still haven't written any code. That's really frustrating. And the thing is, I don't even think I've done it right. Like, I'm pretty sure I've left some security holes in there, because that's not my main concern. So infrastructure as a service helps some, because I didn't have to go buy the hardware, but it doesn't help me with a lot of the other pieces. Software as a service. So I'm sure everybody knows what this is. If you take your enterprise hat off, who do you think the largest software as a service provider is? No enterprise hats. I know you want to say Salesforce. That's your enterprise hat. Who's the largest software as a service provider? Probably almost everyone in this room uses them. Yes. Exactly. Gmail, right? Everybody has 2 or 3 Gmail accounts. There's about 6 billion people in the world, so there's probably 12 billion users of Gmail, right? So that's large software as a service. The benefit to that is I don't have to set up mail servers, right? I'm not doing all that. And I even have a web interface that's good to go. I don't have to set up POP clients and all that other stuff if I don't want to. The drawback to it is I get what I get and I don't get upset, right? There's minimal configuration you can do to Gmail. And as a developer, there's not much I can do with Gmail at all, right? I can't really take that. There are some APIs, but it's not a really robust set of APIs that I can do a lot with. So platform as a service is kind of the meeting place of the two of those. With platform as a service, and I'll show you this in a little bit, I actually say, I want an app, I want it with Python, and I want it with MySQL, go. And I get all that spun up. I don't have to worry about the OS, I don't have to worry about any of that stuff, and I'm ready to go. And the benefit for sysadmins is they control what actually gets spun up. Once they configure it, that they don't have to be in the process of delegating stuff out to me. I can self-provision, okay? And so Red Hat's product for this is called OpenShift. So, and this is where I'll let the people who were at the other talk give the help on this softball, because sometimes people don't get it. Since we're Red Hat, all of our products are what? They're open source, right? So OpenShift Origin is our upstream project. All code goes into Origin. For the versions that we had previous to the one we just announced today, where it was just one code base, every 3 weeks we would release that into OpenShift Online. And this was a new business model for Red Hat, where we actually took the PaaS and hosted it in Amazon, right? And so all you had to do is give an email address, sign up, and you just do your command line stuff, and you're away and going, right? And so every 3 weeks we'd iterate that. We have over 2.5 million apps that have been created in there, right? So that's a lot of users, and we would use that, and we still use that to give us feedback on how to build a PaaS also for the enterprise space. So once a quarter, basically once a quarter, we release OpenShift Enterprise. And that's where we took all the bits, bundled them up, and then make it like that you can install it anywhere you want. So it could be that you're installing it on bare metal, but it could be that you're installing it on a bunch of VMs, or it could be that you're actually go back and install it on your own part of Amazon that you wanted to run, but you just want the automation pieces on top. Right? So as an analogy, OpenShift Origin, Fedora. OpenShift Enterprise, RHEL. Right? And then OpenShift Online is something brand new that Red Hat's never done. These are all the pieces that come out of it, and this is where developers get happy about this, right? Because once the ops team has spun this up for them, or they sign up for OpenShift Online, they don't have to, I have to stay up on the screen because we're videotaping, but I'll use my laser pointer. They don't have to care about these pieces, the hosting and the OS, right? You as the sysadmin, who's sysadmin in this room? Nobody. Good. So your sysadmins can set this up for you. Now I can bash the sysadmins as much as I want. They can set this up and put it wherever they want to put it. But then once they've done that, you get access to Tomcat, Apache, JBoss. We actually even have Zen Server in there if you want that as well, right? And then out of the box, you get Postgres, Mongo, MySQL. But we can also do custom cartridges. So this is version 2, was custom cartridges. In the new version, these are all any Docker image. Right? So you can't find a good Docker image, or your ops team builds you a nice Docker image, or somebody on your team builds a nice Docker images. Sorry? For version 3, which is not an online that I'm demoing, but it's in enterprise. This all becomes Docker images. This does too, and this does too. With the new version, we'll have certified versions of Apache and JBoss and Tomcat, and everything that we have here, we'll have certified versions of that that'll come out of the box. But the new benefit now is we don't have one right now that's a certified Redis. But Redis Cloud has produced one, or at least the Redis community has produced one. You can just run it. In my workshop, I'm doing a workshop tomorrow, and then another one on Friday. That's a hands-on lab. We'll be using OpenShift 3 as a developer. And we'll spin up a Fedora Apache image straight off a Docker Hub. Okay? You get all these languages out of the box. The sysadmin can say, look, no one at my company is going to we've decided as a company nobody's using Perl. And Ruby's just for hipsters. So we're going to get rid of those 2 cartridges in enterprise, right? But they can self-provision among these languages internally. On online, you get all of these. They may also say, we have 3 different versions of, or maybe 4. No, 3 different versions of Python. We have 2.6, 2.7, and 3.3 in online right now. In enterprise, they may say, you know what? We've made the break. Everybody has to be on 3. And so the benefit, you're excited because you're like, oh, I get to self-provision, and I get to spin up my app anytime. I don't have to talk to anybody. The sysadmins are excited because when you spin up your Python app, the directory structure, the way it's configured is going to look exactly the same for every single app. Right? And so if you take it to them and you say, I want this to go into production, or they're not dealing with 15 different ways that everybody's making their Python application and installing Apache and what configurations they're setting. Right? So yes, developers do give up some in this model. Right? You can't go in and tune every little thing that you want on your app server. But the benefit you gain from this is you don't have to worry about any of that anymore, and you get to write code, which is the thing that you wanted to write in the first place. You can work with your ops team to say, look, when you put mod, well, what kind of developer? Who's a Ruby developer? Java. So is everybody's Java, so I should just use my Java examples? So you could say, look, when you, an EAP or Tomcat? Fuse. Actually, there is Fuse for, what? Leave. Tomcat? So I'll just use Tomcat because everybody understands Tomcat, right? So you could say, look, the max memory settings, we should set it like this when we install it. The sysadmin then sets the cartridge up that way, and then when they do it, every single time, it's going to be set that way for everybody who does it. I'm sorry, I just missed you guys in the front. Fuse? Java? Tomcat? EAP? Both? Tomcat. Okay. And then, because we're using standard packages, and I already know about you, so I'm not going to ask. And then because it's just standard open source projects, any of your normal frameworks work on it, right? So Spring works fine out of the box on our stuff. If you're a Spring developer, you can do that, right? It's not a problem. We have Jenkins built in. So if you do any of that kind of stuff, you can actually just spin up a Jenkins server and use it directly in your projects. For all the Java stuff, we build with Maven. That's our build tool. So if you're used to Maven already, you can use your normal, we give you a build, a POM, but if you want to use your own POM, you can use your own POM. How many of you are Eclipse users? How many of you are IDEA, IntelliJ? How many of you are VI or Vim? You were checking your email, and now you're busted. What do you actually use? What IDE do you use? IDE? Development environment for coding. Eclipse. Eclipse? NetBeans. There's actually blog posts about how to use NetBeans with here as well. I mean, we have tight integration with IDEA and Eclipse, but because we just use Git and SSH, you can use any IDE that understands Git and SSH, right? The things that Eclipse and IDEA bring is you can do stuff like, instead of using the command line, you can actually spin up your whole application from within the IDE. And then we also have things that are completely packaged applications. So there is a LifeRay example. You can't use it by default on the free tier because LifeRay, how many of you have ever stood up LifeRay? Anybody stood up LifeRay before? You haven't, but you know about it. It is one of the most memory intensive apps I've ever seen. So in our free tier, our memory we give you 512 megs of application RAM. You cannot spin that up. You cannot spin up LifeRay and 512 megs of application RAM. It's not continuous RAM, right? We use containers, so you're not paying for the OS. That's not the memory that you get. It's for your actual application. Okay? But like, for example, if you have a group that does a lot of WordPress, we actually have a WordPress quick start. So that's the templated app, right? They basically can spin up their own WordPress instance with one mouse click. I'll show that in a little bit, right? The benefit to that also, well, I'll talk about it as we get to it rather than doing it all here. So how we make the sausage? So we use Linux containers. This is not LXC, right? So some people say, oh, you're using LXC. No, right? We looked at LXC early on. In version 2, we use our own Linux containers. In version 3, our Linux containers are Docker. Right? We looked at LXC early on and thought it was not secure enough. Right? And what we really like about Docker, it's containers, which we already liked and we had a lot of expertise with, but it's got the layering built into the container, so you can put different layers in and change just the layer parts, and it's also a really good specification for how you package up an entire thing, an entire app. Not the application, but like an app server. It's a really good way for that, and so that's the part. And there was a lot of ecosystem around it. We also have years of experience supporting sysadmins and devs on Linux, right? And containers are basically a Linux technology for the most part right now. Microsoft is doing a lot around it, but for right now, you have to be on Linux, and it's part of the kernel. And so we've got tons of years of experience doing that. That's why we were using, in version 2, the one I'll be showing, we're using C groups, SC Linux, PAM namespaces, a whole bunch of really deep kernel technology to make our own containers. And then when we all decided that Docker was the way forward, Dan Walsh, does everybody know who Dan Walsh is? Have you been to Red Hat events before? Dan Walsh is the main contributor who put SC Linux into the Linux kernel, right? And he was the one writing the SC Linux rules for us in our stuff. Well, as soon as we decided Docker was the way forward. Dan Walsh is the person working with the Docker team directly to put SE Linux into Docker, right, and to work on the security constraints. One of the things that we do always is work upstream. Right? We don't take a fork of Docker, put our fun stuff in it, because then for lots of reasons, that's just not the Red Hat way. Right? So we are the second largest contributor to the Docker project as a company. We're the new project is also Kubernetes. Is using Kubernetes for container orchestration. We're the second largest. We have 4 of the top 20 Kubernetes contributors are Red Hat employees, 3 of which are OpenShift employees. Right? So we make the changes upstream and then consume it ourselves later. And then the other idea is that you automate that which can be automated. And so the idea here is, you'll see when I spin up an account, no one's going in and creating a user. No one's going in and creating permissions. No one's going in and making the place where the Git repository is supposed to be. No one's actually updating DNS entries. Right? It's all automated through the platform as a whole. And that's how you achieve scale. Right? And that's how you achieve agility, because you don't have the person in the way of doing those things that can be automated. So for example, another customer I was meeting with, to get a public URL was like an act of God. You needed like a stack like this, and it had to be signed by like 15 different departments. And in the end, the network security team was the one who had to sign off on it. Right? So it was a non-trivial task. And so they said, well, look, when we bring OpenShift inside, this is how we'll be publishing DNS entries. Can you give us this part of the namespace where we'll only publish into that namespace using the platform as a service? And these are the scripts that are going to do it, or the pieces of the platform that are going to do it. Like, oh, it's automated? Sure, go for it. Now they can publish however they want into that namespace without having to get approval from the security team and the DNS team. Right? People tend to trust, like I said this in the session on Monday, but the problem with Chernobyl was not the technology, right? The problem was people messing around with stuff and manually breaking things. Right? So there's a lot of places that we currently don't automate that would make life a lot better for everybody if we could. Doesn't mean you can automate everything. And so this is also said in the Monday session, right? But I think what happens here is, I got this statement from my therapist, and she once said to me, Steve, clear boundaries, infinite possibilities. And I think this is what platform as a service sets up, right? What a platform as a service like OpenShift sets up is, sysadmins, this is the stuff that you do, and you don't need to talk to the developers except a few times maybe when we're first setting it up, and then developers don't have to talk to you. And developers, these things are no longer your area of concern. You're responsible for the app and making sure the code runs and doing all this stuff. And so everybody's clear about where that boundary is, and they don't have to fight about who's responsible for this and how's this going to get done, right? It becomes a much clearer boundary and separation, and everybody can do what they need to do in their sphere where they're given full permission to do whatever they want to do, right? We use SE Linux, and we believe in SE Linux so tightly in this that in OpenShift v2 and in v3, we allow you to download any binary you want and run it on OpenShift. I have a blog post that talks about running a Minecraft server on OpenShift. Right? Because we're running containers, and SE Linux is blocking that container from doing stuff it's not supposed to do. Even if you get a root escalation privilege, so let's say you're like, oh, I'm going to write my own root escalation binary, run it on OpenShift, and then I've got the whole thing. No, you've got your container, you've got root in your container running in the context of the user. Right? So it sets up these clear boundaries where people can start to relax about, as a developer, you can totally mess up your containers in your app. You can completely hose it, but you can't do it for everybody on the machine. Right? So that's part of what this allows for. So enough talk, code. Right? Or do people want me to talk about more slides? Yeah. Yeah. There is, so the newest version, I think it was announced, it's released in beta right now. There is Eclipse tooling from the JBoss developer tools team that the new version, it's just a normal Eclipse that you would run on your laptop. But from that, you can actually spin up Docker images, But you can also spin up a Docker image inside an OpenShift v3 cluster. So from right within the IDE, you can do all the stuff that I can show if people want to see v3. I can show from the web console or the command line.
Okay, so once I finish writing my code and I check it in,
Yeah.
what moves between the environments? The code that works in the dev environment, that goes through?
In v2, it's just code. Okay. V2, we only do changes and management around code. The containers is the containers, and they're the same for everybody. In v3, it depends on what you want to move around. You can move around the entire container or containers. So basically, you can dev on your local machine using like the VM that I have set up. At the end of the process, you have a Docker container that is your application plus the container to get your code plus the container together. You can just take that Docker container and publish that to OpenShift if you want, right? Or it could just be, this is the code, and I know it works with this container, and I'm just going to pull the two down together up on the server. It just depends on the model that works for your company. So I think 2 is a bit simpler to understand and to work with. So the job for us with 3, it's a lot more flexibility and a lot more power. And so what always happens with any product or any tool in general, this is a tool like any other tool, the more power and flexibility that has, the steeper the learning curve. Right, so you'll see our team start producing more documentation and learning tutorials about understanding the architecture and the power that it gives you. Okay, that part will be coming. So the first thing I'm going to do, this is what I'm going to do. I would do a Java app to start with, since we're all Java developers. But how many of you guys all said you worked with Maven, right? Yeah. So when you do a Maven pull or Maven build for the first time, what do you spend the very first time? What do you spend most of your time watching? Downloading the internet, right? All those jars getting downloaded. So it doesn't demo well. So if you're fine with watching me download the internet, I can do that on the first build. But if you want to see the same process but much faster, I can do it with Python. I can do it with Node too. I don't do it with Ruby just because. So I like to pick on Ruby all the time because they're like the people that we're all Java developers. So way back in the day, I used to be very sensitive as a Java developer. People would pick on Java, and I'm a Yankees fan. I know that's a little bit dangerous to say here in Boston, but it's part of the. And I'm not a huge baseball fan, but it was always fun to be a Yankees fan around Boston fans because you could tease them just the littlest bit, and they'd go right through the roof, and it was always easy. So like that's how. Now you know more about me as a person as well. So I feel now like the Ruby developers are the Java developers of before, where you tease them the littlest bit and they're totally hypersensitive about it. So it's kind of fun for me. I think all languages are tools now. They all are good for different purposes. I just happen to be most comfortable in Java. That's why I use it. But do you guys want to see Python? That was a long way of getting to. Is it okay if I just do Python, or do you guys want to see me download the internet? Python's fine? Okay. Sorry? So let's go ahead and do that then. So I'm in a directory that I want to be in because I'm going to do a git clone at the end. That's why I moved not into my root directory. So RHC, app create. So RHC is our command line tool, right? And the only time you're going to actually use this is when you're doing infrastructure-like things. As long as once you've done that, everything becomes git and SSH. Okay? There's nothing that you need our tools for, other than for infrastructure stuff. So we're going to call we'll call our app should be Java. How's that? Right? And we'll do it in Python-2.7. And that's it. Right? So what this is now doing on the server is, first the message went to the broker and said, hey, I need a new container for this app. It creates a user for that app. That app gets a UUID. Then that UUID, it starts making the container, right? It does the C groups, it does the SC Linux permissions, it does a whole bunch of stuff. It allocates a PAM namespace. Then it makes a Git repository on the disk. And then at the end of this process, towards the end of this process, you're going to see it say, waiting for DNS entry to publish. We don't actually give you an IP address at the end of this. We give you a canonical URL. And so we need that to propagate so we can do the Git pull. Right? And so now we wait for while this happens. And it is relatively quick. Any questions while this is happening? Someone should ask some questions just to break the silence. Should I talk more about other people I like to tweak? I'm an ecologist by training, and I usually studied animals. Plant people, botanists, are just as easy to tweak as Red Sox fans. In case, if you're ever around a botanist, you just say, yeah, but you only study plants. Animals are the only things that really matter. Guaranteed to put them through the roof. This is slower than I was expecting it. The Wi-Fi is not what I was expecting. Am I on? I bet you I'm on Heinz. Oh no, I'm on mine. There we go, it's done. So what's happened now? Oh, there was other things I could have told you that was happening. Of course, now I remember. So we're done. And once the fingerprint, because we're using containers, what it actually did when it spun up Apache, because we're using Apache with mod WSGI for Python, it actually spun up an instance of Apache just for that application, right? So on that node, if there were 30 other Python applications there, there'd be 30 other instances of Apache with mod WSGI spun up just for that. It's your own instance, shared nothing. Right? So everybody gets their own instance of what's running. But the nice part is it's all running from the same binary underneath on the node. So the node is a big rel box that we're spinning these all up from. So let's say Heartbleed comes out again, or something like that, and we need to patch all Python 2.7 applications. All I have to do is replace that one binary on the node, kick all my Python apps to restart, and they're all patched. Right? It's not like a VM where I have to go into each individual one and patch it. Okay? Question? Nope, we're good. So the app is up. You can see we actually published an address. Oh, that's the other thing. We do dynamic DNS. There's the app. It's pretty exciting, huh? I've trademarked it. Don't think about copying it. I'm going to make a lot of money off that. You'll notice that all of them are star.rhcloud.com. All your URLs will be .rhcloud.com. It's app name my namespace .rhcloud.com. Right? And that's on the online version. You could actually CNAME this, right? So it could be www.myapp.com. That's not a problem. You can do that for free. We also give you HTTPS out of the box for free. Right? So this is actually right? That's HTTPS. The only thing that we don't give you for free is if you CNAME this, right, and you make it myapp.com, the cert is for star.rhcloud.com. So if I do myapp.com, it's going to throw an error saying the cert doesn't match the URL that I'm doing. If you want to publish your own cert, you pay like a monthly fee or something like that. Now this is what the code change looks like. So I cd into should be Java, right? And you can see that's a Git repo. One of the other things is by default, with all our servers, we shut them down and start them back up every time you do a code push. For Python, that doesn't have to happen, right? There's no compiling that happens, so we don't actually have to shut the server down. The same thing with Java, right? We should be able to hot deploy. New war file, I just upload it and you deploy it. So we can go into this .OpenShift directory is for metadata that affects the app. So I can go into cd.OpenShift, and it's called markers. And there should be a marker in there. There's none in there. I was thinking of a Java app. The Java app would have a Java 7 marker. You could delete that and you'll get Java 6, I think. I don't know if we still even support that. But what I can do here is touch hot_deploy. Right? And so that marker there says, hey, don't shut down the server. Just build the code and push it. And build in this case might be, so in the same way that we have the Maven file where it's going to declare all the dependencies and then download them, in Python land, that's going to be in your requirements.txt. And also could be in a setup.py. So inside of this, there's nothing in it. I can declare any dependencies, and at build time, it'll download those dependencies, put those into my container, and so the next time I do it, it's not going to download them, and it'll have all the dependencies there. So you don't have to bundle up a file and then push the whole file up. It'll automatically build and download the dependencies. All right, so let's make a code change. So what was this again? Right, so WSGI.py is that page. And I am so ninja and lightweight that I'm going to use Nano. VI and Emacs are too heavyweight for me. It slows me down. Too many key sequences, too many commands to remember. I just need one blade. It's just that I can never remember all the keystrokes and sequences in VI and Emacs, so we're going to say H1 tag. There. So that's that welcome to your Python application on OpenShift. We're going to edit that. Welcome to an app that would be better in Java. Okay, that's our complicated code change. We save it. We git add. Because remember, I also have to add. Does everybody here use Git? Or if you haven't, because I'm not noticing all the heads shaking, you should. Or at least some distributed system, Subversion is going away. I mean, it's not going away. There might be, I can't think of any, but I really have a hard time saying no one will ever use this tool again. But Subversion is going to become a smaller and smaller portion of the version control people will use. Git has obviously won that kind of war in terms of what's the version control most people are going to use. Yes, I did. There. So now I've added them. Now I commit them to my local Git repo. Move this up to the top of the screen. And then I just do a git push. Right? And so this is now taking what's been committed to my local repository and pushing it up to the server. So there the push is done. There it says not stopping cartridge because hot deploy is enabled. It's doing a build. This is the first build it's done, and it's done. And so now I reload my page, and my code changes there. So that becomes, once you've done the RHC command or in the IDE, you've said make this app, the rest of your flow is SSH and Git. Okay, that's your deployment, that's your work cycle now, which is no different than most work cycles as it already is. The difference is I didn't have to have anybody set anything up for me. I said, I want to try, like, this, so this is how hard it would be if I wanted to try Node and Mongo, right? RHC, app, create, experiment, Node.js-0.1, MongoDB-2.4. I think it's 2.4. I'm going to actually now use a larger container size, so it's medium. So this is now going to be a gig of RAM, and I'm going to make it scalable. So what that means is, by default, if I added another database to my Python application, that would have put the database inside the same container. Right? And so they would be competing for RAM. We give everybody a gig of disk space. They would have been competing for disk space. They would have been competing for CPU. If I make it scalable, it says put each of these in their own container group. One container each to start with. That way I can actually scale up the node piece without touching the database piece. And they don't compete for memory. They don't compete for disk space. Right? And we would also put HA proxy in there, just so that we could load balance among all the app servers. So that's what it takes to spin up Node and Mongo together. Right? Yes. I'm using the online version. Do you want to see what it looks like in the new version?
No, just understand. You are creating an application on how many gears?
The first one created 1 gear.
The second?
And even if I added a database to the first one, it still would have used 1 gear because it would have put the database into that same container. The second one is going to use 2. One for Node, one for Mongo. HA proxy to start with is going to be on the same in the same gear as Node. Okay, does that make sense? Okay. So okay, that's all great. Everybody understands the dev workflow now? Feel good about that? Hopefully. I'll open up another terminal. I'll make it a bit bigger. Let's go back into, should be Java. So because I use the command line tools to do this, I can use a little shortcut to SSH in. Right? You could also just type SSH with that long user string and the URL that we use for the web server. Right? By default, the only ports we open to the outside world are 22, 80, 443, 8000 and 8443, and those 2 upper ports are for WebSockets. So if you want to do you want to play with WebSockets, it's going to be routed up over those ports. Okay? So we're now actually SSH'd into our container. We're in the container inside that large node. So the first thing that I'm going to make the font a little bit smaller. Can everybody still see it? Just so we have a little bit of room in the command there. What's the first thing that most developers, they're going to do this. Oh, okay, that's great. Then what's the next thing? Don't say rm-rf, because most developers are smart enough to know that they shouldn't try to kill their machine that way. But what do they want to do, right? The next thing they want to do. No, what? Yeah, we can do it. There's PS. What's the next thing they want to do because they're naughty? Yeah. They're going to want to do this. No. You are not allowed to be the administrator on this container. Right? It's not allowed. What you can do, because in this model, actually, in version 3, you can be the administrator inside your container. In this model, you usually do the reason why you would want to do sudo su is because you want to do RPM, right? RPM install, and you can't because we're on that big rel instance. So if we allowed you to install an RPM, every other person on that machine could get access to that. You could install a bad binary in there. So you're not actually allowed to touch the underlying operating system because as a developer, you shouldn't care, right? You can't even make files in your root directory. Permission denied, right? We do give you 2 different spaces to write to. So usually with /temp, what's the permissions for that? What's the Unix permissions on /temp? Why would you, if you were writing an application on a multi-tenant machine, why would you not put things in /temp? Sorry? Yeah, the permissions usually for /temp is read, write, execute for everyone, right? So what's actually happening here is we're using PAM namespaces to give you a unique directory that's some random string, but to you looks like /temp. So yes, it has read, write, execute permissions for everybody, but nobody else can get to it, right? In this space, the files that are there are ephemeral. If you shut down your container and bring your container back up, there's no guarantee those files will still be in there. If you shut down your app and start it back up, there's no guarantee. This is one of the differences between us and all the other PaaSes is because of this next directory I'm going to show you, this one, I can make a file here. Oh, we're cutting off that side of the screen. I can make a file here, and it will survive in between stops and starts. Not destroys, but stops and starts, right? So that's actually why I was able to add a Mongo database instance directly in the PaaS. Every other PaaS in the market right now, they make you do what's called a 12-factor app. Have you guys heard about 12-factor apps? It basically is the new style where there is nothing stored to disk. And so if you wanted to use a database, you have to call out into another service, not in the PaaS, because they can't write anything locally to disk. And so in here, we say, yeah, you can do 12-factor app if you want, but you can also do an old-school style app, just like we do here, right? So and I'll show you in a bit about Mongo once that's all up. It should be up already. Oh, wait, I should be there? Otherwise, that'll time out. It timed out. It didn't do the git clone, because I didn't say yes in time. So I can just do this, rhc git dash clone. I forgot the app name. What was the name of that app? EXP. There we go. So that's going to actually do a git clone now. Okay. So what is something that when you're doing your own app, what is something that you usually do need to actually do? Like when things go wrong, what do you want to do? You want to look at your logs, right? And that you have full control over because that's something devs should be able to do. So if I do, there's 2 different ways to get to it. We give you a whole bunch of environment variables. So OpenShift, log, directory, right? That also is AppRoot logs, this part right down. It's the same thing. Instead of AppRoot data, it's AppRoot logs, but you can also use the environment variable. And in here, you can see there's a Python log. And I can grep against Python log, grep the against Python log. Let's see if I get anything. There we go. So there, I'm grepping against it. But I can also, gone. Right, I can do anything I want with the log files. Because we're using SSH, you can also SCP those log files down to your local machine if you want. Right, there's no problem with just using your normal SCP tools. One of the other things that, I'll show you this before I do that though. So what do you notice about when I run top, about the user ID? If you did top on a normal Linux box, what would you see in terms of those user IDs? Many user IDs, right? Most of my questions are, don't be scared. They're pretty easy questions. I'm not here to, this is not your master's defense or your PhD defense where I'm trying to trick you. There would be many user IDs. But because of what we've done with SC Linux and C groups, you can't see any process besides your own. Okay? So yeah, you can kill any of those processes you want. But you have no idea who else's processes are running on the machine. Okay, so as a developer, you can do the things you're used to doing as a developer. You can run top, you can run ps-auxw, you can run lsof, you can do that kind of stuff. But you can't see anybody else's stuff, because that's not nice. You can't touch anybody else's stuff, right? But because we also use SSH, so on this app, let me go into EXP, right? And wait until you see what this page looks like. You're going to be shocked. EXP-SB demo. Look at that. Huh? That's a fancy page, isn't it? Yeah. What we can do with this exact same, I'm not going to go through the flow again, but I can do this. RHC port-forward. Because I'm in the Git repo of the project, and we created that with RHC git clone, there's metadata in the Git repo, so it knows what app I'm talking about. Right? So now what it's doing is it's actually going and looking at the app and port forwarding all the ports that it's trying to connect on back to my laptop. So now if I had a Mongo admin console on my local machine, I do this all the time with Postgres. Or if you do, any of you use MySQL or Postgres, right? There's an admin console, I use pgadmin. I'll port forward like this, and then where's the Mongo? There's Mongo. 127.0.0.1, port 59401, and I point my admin console at that, but I'm actually talking to the database on the server. Right? So even if I'm deving my app locally, I'll turn on port forwarding, and I'll have it talking to the database up there so that I'm actually going against the real database. I don't have to install the database locally. And so how many of you have used Mongo so far? A little bit, and just one other person, right? And you're like, I don't want to install that on my machine, and how do I get it installed, and how do I get it running? And ready? RHC SSH. All you have to do is on OpenShift create an app with Mongo in it. And now I'm in. So I have my own Mongo instance to play with. Do whatever. It's a normal Mongo instance, just like any other Mongo instance. You want to start playing with it, writing code against it, you're good to go. Nothing to install on your local machine to mess up, spend a week trying to figure out if you installed it correctly, or even a couple days. Just go right away. You're reading a blog post and they're showing some cool things. You're good to go, right? The other thing is, so we try out Node, we try out Mongo, we're like, that's just for hipsters. I don't want to waste my time on that anymore, and I don't want to waste those resources. RHC app delete exp. And it says, are you sure? Yes, I'm sure. And that's it. Both of those sets of containers are now destroyed, and I have the ability to use those gears or containers for other purposes. And that's it. Right? So it's very easy to experiment and try some new technology, and then just throw it away when you're done. So this is also why the sysadmins love this. Right? Because let's say they've never played with Node before. When you come to them and say, I want you to install Node, and give me a VM with Node, they actually have to sit down and start learning and mess around with it. Here they can just say, okay, well, I put the cartridge in, it's enabled, go play. When somebody writes something real that's worth it, then I'll learn more about it. But you don't have to bother me anymore about it. Right? They don't like getting phone calls from you either. Right? There's been no sysadmin that I've ever heard. It was like, I love it when you call me and say that you need some VM with this new thing installed, and you need it installed in your own special way. And do we usually say, well, I'll need it in like 3 weeks. No, it's usually like, I need it by tomorrow. I'm waiting, right? The other thing that we do that also makes sysadmins happy, how many of you get VMs when you get dev instances? One person? You get VMs, like when you call your sysadmins and you say, I need a dev instance to try stuff out, do you get a VM or what do you get usually? A VM, bare metal? Who gets bare metal? Nobody, right? You get bare metal, really? That's awesome. But you get a VM. So then when you're done playing with that dev instance, how many times do you call your sysadmin up and say, yeah, you can have that VM back? Never. Years, exactly. So then what ends up happening? Then they send out emails once a quarter or once every 6 months saying, we're going to garbage collect VMs. The following are on the list. If you do not claim this VM, we are going to garbage collect it. And then you ignore that first one. And then they send another message another week later. And then you ignore that one. And then you ignore it and you ignore it. And then they get rid of it. And then you yell at them. And they're like, yeah, well, I didn't delete them all really. Something, I just turned off the IP to it. And then you have to bring it back. But they are still buying lots of hardware because you guys never give your VMs back, right? Because once I give memory to a VM, it's away from the system now. It's not available to others on the system. With the container, yeah, I have access to 512. But if I'm not using 512, then I'm only going to be using, if I'm only using 20, like let's say Apache's only using 25 megs of memory, that's all that's going to be used by that container. It's not like it's not available in the system anymore. But the other thing that we do is what's called auto-idling. So I can't demo it because I'd have to wait 24 hours. But if you don't access a system, one of your systems, you as a developer or a user comes into the system, there's no HTTP request for 24 hours, it gets spun down and serialized to disk. And that's configurable in the enterprise version. Your sysadmin can set it to whatever. So instead of now consuming memory and CPU and all that other stuff, it actually is just some disk space, and disks are cheap. The next person who comes in and wants to use it, they have to wait a little bit. And since most of us are writing Java apps, they have to wait a little bit longer because there's more resources that have to get spun up. But it'll spin up, and then it's up again for another 24 hours. But so what this means is all of our, like, I'm going to make the best app ever, and I need a VM now, and I'm going to spin it up. And then you never touch it again. You never do anything with it. You thought it was this great thing, but it's just sitting there chewing up memory. It just gets serialized to disk. Nobody has to bug anybody else about we're going to garbage collect this, we're going to do this or that with it. And that memory is still available. So they're using much less hardware to meet your demands for new and exciting machines all the time. Right? So that's another benefit. So I'm trying to show how it helps you guys, but how it also helps your sysadmins, but nobody's really that upset about what's going on. Yeah?
So the Docker containers and scaling and all that factors included in production, how do we keep track of logs? We have multiple scaling factors.
So the way you keep track of logs, the general story for that right now is you would use another service like log entries, Loggly, Splunk, something like that, where you have a general log drain, right? And each app knows it's an environment. Oh, that's one of the things I didn't show you. So if I go back, I deleted that app. I can't go into that app. Let's go into this one. RHC, SSH. What we do is we insert a bunch of environment variables. I should have kept the other app around. I should have deleted this one. Because it would have shown you that here we put a whole bunch of environment variables in. Like one that would matter in this one is the data directory. So in your app, you wouldn't say, if let's say you're uploading files in there, you wouldn't say, upload my files into this long path. You would say, upload my files into OpenShift data directory. That way, if someone else takes your exact same Git repo and spins it up, they will get a different path, but they'll still have the same environment variable. So this is a long way. It's going to be a long way, but I'll get to your answer. One of the reasons why this is also awesome on a team is you can have a Git repo that's all set for this is our app. A new team member comes in. You say, okay, RHC app create, Java, Postgres, this Git repo, because I can actually do that in the command line. I can say -- from code. And the new person has she has a completely new server instance running with the full application. No first install this, and then install that, and then make sure you have access to this repository, and then turn on these permissions, and blah, 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 blah. No, it's just go. So they're productive right away. What you could do here is you could put in an environment variable in that says, this is the logging directory. Or this is our API key and the logging server address. And then turn on the logging agent. For Loggly, that's what you do. You have an agent that collects the logs and does that. And it puts in the key and all that stuff in an environment variable. Right? And that's coming in 3. It's not in there right yet, but we'll be building in a log drain. Because yeah, you're right, when you scale up to like 3 instances, 5 instances, 6 instances, you need a log drain because you need to be able to say, oh, I'm getting exceptions, where am I getting them? You don't want to have to SSH into each machine and figure out which machine is the one throwing the exceptions, right?
One more question.
Yeah.
If I have services that need to talk to each other via REST,
Yeah.
what would it look like that? The like .orangecloud.com /contextpath/
Yes. In this version, yes. In version 2, you would have to hard code those URLs in. In version 3, so I'm pretty much done with most of this talk. I'm going to switch to a little bit about what's changing in version 3 now. In version 3, we get rid of the idea of an application. Right? There is no more, like in here, one of the things that it's a little bit clunky that's still due in version 2 is, and I would get this question a lot, is I want to use one database for two different applications. Right? So I've got a Python app and a Java app, and I want them to use the same Postgres instance. Or I've got 2 different Python apps, and I want them talking to the same, or 2 different Java apps, or whatever, or 5 different apps, and I want them all using the same database. We automatically insert the environment variables in one app. Right? So if we had looked at the environment variables in that Mongo and Node app, there would have been all the usernames, passwords, URLs for the Mongo instance in the Node app. Right? So it would automatically know how to talk to the database. The problem is it wouldn't get published to any of the other applications. You'd have to hard code in those URLs into the connection parameters. Right? You probably would make an environment variable again in the other one, and then you'd have it point to that URL, but you would still have to go in manually and do it. In version 3, there is no more app anymore. There's a project, and that is a collection of services. And some of those services you might choose to expose to the outside world, and some you don't. Right? And everything within a project knows about the environment variables for the other things in the project. So in that case, if you were spinning up a bunch of different REST services, you would actually talk service to service. You could actually talk directly service to service without having to go back out and back. Like, it doesn't really actually go back out, but it goes down the network stack and then back up the network stack. Here, you can just be right inside the software-defined network, going straight from service to service. Right? So in this one, yes, you'd have to spin up a new app. Like the microservices app, I have a in the talk. You remember you saw my microservices app? You notice they all had different rhcloud.coms, and they're making connections between them. Once I'm comfortable enough with version 3, I'll be rewriting that way, and those will all be services in a project. And they'll probably just be one URL, and that one URL is just talking to the public-facing web interface. Or I may expose them all as separate routes, but I can also talk directly along services inside. Does that mean we're out of time? Any other questions? So let me just do the wrap-up slides. It's been a long day. Thank you all for sitting through all this. I really appreciate it. I didn't even show them. That's okay. PaaS makes life great for you, whether you're the sysadmin or the developer. You can live your dreams. This is the best of all possible worlds. The reason actually why I put this one is, so there's a bunch of different PaaSes on the market. I think ours is the best. Even if you are going to use ours, I suggest trying 1 or 2 others. You guys have seen our other customers here, right? And so those are the companies that are using PaaSes. And in general, enterprise customers are slow to move. So think about how quickly people have adopted PaaSes. You will all be writing against PaaSes eventually, right? And once you use it, I can never imagine going back now to using like AMIs on Amazon. I want nothing to do with that anymore. I don't want to waste my time like configuring all that stuff. I just want to write code, and this is what makes it so much nicer. Whether you use OpenShift or another PaaS, that's a feature of the PaaS, okay? OpenShift has a free tier, and there's a free ebook. One of my coworkers and I wrote it. It says, Getting Started with OpenShift, a guide for impatient beginners. So if you want to get to it, that link is there. This talk member is available. But it's also openshift.com/ebook. And that'll get you to the PDF version of the book. And there's the GitHub repo for an app that I didn't show because we ran out of time. And we're all in Freenode. OpenShift is for users. OpenShift Dev is for people who actually build the PaaS. It's all on Freenode and IRC. And then there's users at list.openshift@redhat.com. If you run into questions, you can also ask them there. Okay? Thanks, everybody.